Okay, today we will discuss about the uniform circular motions. Uniform circular motion means the clock. Clock there is a equal number of turn of the minutes hand and the hour hands and the second hands. In day-to-day life there are a lot of the example you will observe of the uniform circular motions. The bicycle of the wheel, the car, the tire of the car, or even the best example of the universe. The earth is taking on uniform circular motions. You know very well. The year, 1 year is completing in 365 days. There is a uniform circular motions. Means every year you will observe. Only in the case of the leap year, that is 366 days. But the earth is taking a uniform circular motions. Like this way. The sun is also there. The sun is on the initial positions. But our earth is taking a uniform circular motion around the sun. And the moon is taking the uniform circular motion around the earth. This is the day-to-day life example of the uniform circular motion. The things that is rotating around the circle with the uniform speed, that we are telling as a uniform circular motion. Means the speed is the constant in this case, and the things, whatever the object, will take a rotation around the circular manners. Now, but here this is an example. The speed of the tip is constant, but the direction of the displacement and therefore its velocity is constant changingly. Now here you look the speed of the tip. They are telling an example. Speed of the tip means the clock hand, the clock tip here they are telling. It is constant one, but the direction and displacement is changing in this case, and the velocity is also changing. But the velocity of the clock, you will observe, it is same, equal displacement and equal interval of the time. This we are telling as an example of the uniform circular motion. Now look an example of the try out and think about this one. They are telling draw a rectangular path. Just see in 1.10 figure. Just place a tip in the middle part. Just they are telling place the tip on your pencil on the middle of any side. They are telling just look the ray. Look the arrow. You will observe in all the places of the sides. Now, how many times you will rotate change the direction? In this case of the square. But if you will increase one of the side, just see an example of the pentagon, and then do in the same manner. Pentagon is there, then the down here hexagon is there, then septagon, octagon. Here, in always you will place a arrow and just observe the number of the turns. In this case, you will observe there is a equal number of the turns are there. So this we are telling in uniform circular motions and examples. But once you are increasing the number of the side, that much of the turns will be there. So here speed, whatever the object is constant, and the speed along the circular part, velocity, is always changing in the directions. Your object is always in a constant manner, and the speed, whatever the speeds are there, जो speed बोलते हैं ना जो circular part में, वो कांस्टेंट रहती है, बोलते हैं ना चेंजेस होते जाती है उसकी स्पीड, बट जो डायरेक्शन रहेगा ना वो चेंज होते जाएगा. मतलब जो स्पीड तुम्हारी क्या है कांस्टेंट है, वेलोसिटी कांस्टेंट रहेगी, बट जो डायरेक्शन तुम्हारा क्या होते जाएगा इसमें चेंज हो जाएगा. एज एन एग्जांपल ऑफ द एक्सीलरेटेड मोशन. बट व्हेन द ऑब्जेक्ट, वी कैन से द ऑब्जेक्ट्स आर मूव्स, जो बोलते हैं ना ऑब्जेक्ट अगर कांस्टेंट स्पीड में मूव होता है सर्कुलर पार्ट में, तो इसको हम लोग क्या बोलते हैं यूनिफॉर्म सर्कुलर मोशन. बोलते हैं ना कोई भी ऑब्जेक्ट जिसकी स्पीड सेम रहेगी और वो सर्कुलर मैनर्स पे मूव होगा तो उसको यूनिफॉर्म सर्कुलर मोशन बोलेंगे. मतलब जो ऑब्जेक्ट है, वॉट एवर द ऑब्जेक्ट दैट हैज़ एन अ कॉन्स्टेंट स्पीड एंड मूविंग इन सर्कुलर मैनर्स, in a circular part, that we are telling as a uniform circular motion. The example of the motion of the stone in a sling, string, एक धागा लो उस पर बोलते हैं स्टोन बांध दो, and then you will rotate, you will observe that is also uniform circular motions. The point on a bicycle tire, just see that you know the very well the tire. In the tire there is a center are there, from the center a lot of the string, we can say the simple lot of the strings, we can say iron strings are there, they are attaching on the wheel. They are also an example of the uniform motions. Whatever the object that moves around the circular part, that is a radius r, we are telling that time interval is there, and they are rotating and coming back into the same speed. Means they are telling if an object moving along a circular part, that is a radius r, and they are taking time interval t, and from the starting point to the final point they are coming into the again in the initial positions, then we are telling here speed equal to circumference of the time. whatever the circle are there, is it possible circle distance to measure with the scale? The circle distance we have to measure with the circumference. The circumference, it is 2 pi r. So in the case of the circular manner, you should know the radius. अपने पास radius होने चाहिए. Here we have the radius, so we count the distance easily of the circular part. So speed equal to circumference upon time. Circumference we have 2 pi r and time you have t. So velocity equal to 2 pi r upon t, means whatever the circular part or circular motion, if you want to find the speed, so you have to take this formula, that is 2 pi r upon t. Distance upon time, but here distance according to the circle, it is circumference. Now determining the direction of the velocity in uniform circular motions. In uniform circular motion, whatever the velocity and the directions. Just look an example, the coin and the disc. The coin and the disc, you know very well, the circular disc are there and you are putting a 5 rupee coin. And once the coin is rotating, once the disc is rotating, what you will observe, the coin will slide in a slowly, and then it will totally out from the disc. That is an example of the uniform circular motion. Now the coin will be thrown up in the direction of the tangent. Whatever the coin will be thrown up in the direction of tangent means tangential direction it will be throwing out. And they are telling which is perpendicular in the radius of the disc. They are telling in the perpendicular of the radius of the disc. Why they are telling is in a perpendicular disc? The disc is in a circular manner and we are putting a coin above there. And once you are rotating, the coin will throw out. The coin will throw out in a tangential direction. Whatever the tangential direction and the circular direction, they are always like in a perpendicular wise. That's why they are telling is in a perpendicular to the radius of the disc. Now you will observe the direction in which the gets out throughout. Whatever the coins has been, we can say throw out. The coins has been thrown out from the disc, and the direction of the motion is always changing according to the motion. According to the motion of the disc. The disc motion is same, but the coin direction is changing. The disc motion is same, rotation is same, and the direction of the coin is always changing, and because of that reason the coin has been thrown out from the disc. If the coin has now, we can say if the disc is not rotating and the coin you will put, so it will not, we can say it will not throw out from the disc and it will be in the stable condition. So here we will see about the Newton law of motion, that Newton 3 law is there. Newton 3 law, you know Newton first law. Newton first law is a inertia, related to the inertia that you have seen the above example, the disc and the coin one. The disc and the coin one is also are the coming of the Newton first law. This is the balance and unbalanced law. First, you know a static object are there, it will stable only, but once you will apply the force then it will move. Is it possible? Without motion, without force the object will move. The force which is, we can say, the sufficient to lift up the book is not sufficient to lift the table. Is it possible? The books you have put it on the table, you can lift the book easily, but is it possible that you can lift the table easily? You will observe that is difference thing, and you can say no, we have to apply the difference force. Now fruits on the tree, you will observe tree fall, from the tree fall the fruits is coming down, from the air it will come out, or we have to shake it, the tree, then it will fall, otherwise it is not possible. Now an electric fan keeps on rotating for some trees, sometime. Now the electric fan, you know, when it is switch on, the fan will rotate easily, but when you will switch off, you will observe it is the speed of the fan, it will be slow down and it will stop. Now your balance force and unbalanced force, the Newton first law. The balance force, the person sitting on the table, or the person sitting easily, or the person sitting whatever the object, just put anywhere, and it will not rotate because it is in a balancing manner. So they are telling an object continues to remain at rest. Hence I have given an example, whatever the object you have put it on the table, but or in a state of the uniform motion. On uniform motion means the things that will move in a uniformly. the speed or the direction will be in the same manner along the straight line, unless when you will apply the external force, when you are, we can say, when the external force you are applying, then the object will move, otherwise it is not possible to move the object. मतलब कोई भी चीज़ तब तक नहीं हिलेगी, मोशन में नहीं आएगी जब तक वो चीज़ को हिलाएंगे नहीं. ओके मतलब कोई ऑब्जेक्ट रखा हुआ टेबल पे या तुम अगर सीट पे बैठे हो, जब तक कोई तुमको आगे धक्का नहीं मारेगा, या जब तक बोलते हैं ना टेबल पे से कॉइन हिलेगा नहीं या लिफ्ट नहीं करोगे, तब तक वो चीज़ मूव नहीं होने वाली है. इसको हम लोग लॉ ऑफ इनर्शिया बोलते हैं. लॉ ऑफ इनर्शिया यू नो वेरी वेल, यू आर हियरिंग दैट लॉ ऑफ इनर्शिया फ्रॉम द 7th standard or 8th standard. When you are going from the bus, suddenly the brakes apply and you are sitting on the table, you are sitting on the bus, chair. So what will happen? Suddenly the brake will apply, your body will come in the forward direction, but the chair is remain on the initial positions. This is the Newton's first law of motion. Okay, we will discuss the next topic on the next time.